This video is going over how to solder the boards that you've all made. So just to get started, this is the most recent version of the board that I made. This is the one that came with all of your circuit boards. So I noticed I didn't modify the silk screen to update those extra things, but that's fine. But this is the latest version. In the last video that I did, this is what arrived. I'm going to assemble everything except for the buzzer, just because the parts for the buzzer aren't here yet. So just to start off, before you get started soldering, you have to make sure you have an iron, make sure it's preheated. If it's a bad one, it takes a while to preheat. You're also going to want to make sure if you're using a sponge with a soldering iron that the sponge is wet. That's one of the biggest things students get going, and if the sponge is dry, they just try to scrape at it to clean the solder wand off, and it really has to be wet or you're just going to ruin the sponge. So we're starting with the board. The first thing, and I kind of show my setup is laid out, so the one thing that's really critical is to have all your parts ready to go before you start soldering. So in this case, it looks like I think I ran out of the 10 microfarads actually. So I already assembled one just to make sure it all worked and everything. But I have all my parts labeled here. So I have, the 20K resistors, 8.2K, 1K precision. I have that transistor that we use for the regulator, the inductor, capacitors. Everything labeled, making sure I have everything I need. I have a couple buttons here which are surface mount, but I'm going to show you how to use them for the through hole ones. So the one thing I'm missing is the 10 microfarads, which I'm going to grab. So I got my 10 microfarads here. Normally what I like to do, in this case I need two, I'll just take scissors, carefully snip them off. Whenever you're snipping reels of stuff, you want to be sure not to cut apart in half. That happens a lot. They're close together. A lot of times the edge of the scissors aren't aligned and people snip apart in half and then they try to use a broken part. So we're going to get started soldering this thing. I'm at a station that's already all set up. So the first thing I like to do is, especially if I'm using lead-free solder, I like to pre-flux the board. And with flux, you can't use too much. So I'm using chip quick flux. So what I'm going to do is I'm just going to go through here and I'm just going to, anywhere there's a part, I'm just going to get a little bit of flux on there. And I'm just kind of smearing it around. It doesn't take a lot, but again, you can't really do too much of this. So this is, especially with lead-free solder, the flux is going to coat the outer surface of the solder, and it's going to make it so that it doesn't form these crystals, because lead-free solder tends to like to form these nasty little crystals that are hard to, once they start forming, they're hard to deal with. So just really quickly, just to see, so I just kind of gooped up that surface with the solder paste, just getting a little bit, making sure I had some on each pad. Once the solder touches it, that whatever flux is on there is going to kind of flow around the outside of it. So as long as there's some of it on the pad, it should be fine. Looks like I missed a little bit here. Okay, so now my board is pre-flux. There's also flux pens. There's lots of ways to do this. What I might do for the rest of this video, I'll see if it works. I'm going to zoom in maybe. Can I zoom in? Yeah, a little bit. Okay. So I'll just zoom in a little bit, get us a little zoomed in here for the soldering. So as I solder this, my technique with soldering is I like to just do one pin at first. So whenever you have a surface mount part, soldering one pin still gives you the ability to remelt the solder and then adjust it if you need to. But once you get two pins down, it becomes very difficult. So I kind of like to take all my parts, solder one side of them, and then I go back and solder the other side of them. I'm going to start with the big chip. So I'm going to start with the strain gauge amplifier. If you look at this strain gauge amplifier, you can see there's like a little, well, you can't really see like that. But I'm going to turn on the light here, by the way. So I'm going to put this in the way it needs to be. You see on the board, there's a little dot at the top left corner of the part. And then if you look at the part itself, there's a little dot at the top left corner. Those need to be aligned with each other. So I'm going to put that on there, just set it on. The other nice thing about using flux is it gives a little bit of stickiness to the surface to kind of help parts stay in place. So you can see now that part, it's aligned. Okay, it's not perfectly aligned on the pad, but it's probably close enough. So that part is now on there with the dot on the chip aligned up with the little dot on the circuit board. Those dots are aligned. If you get this upside down, it's going to ruin the strain gauge amplifier, so you want to make sure you don't get it upside down. I normally solder under a microscope, but since you're not going to all have the ability to use a microscope, I will avoid it. I will just show you soldering without it for now. So to start with that big chip, I'm going to take my soldering iron, making sure the tip is clean. So this tip right now is looking a little messy. I just kind of lightly scrape it across that wet sponge at my solder station, and then you see it's much better looking now if it gets in focus. So now it's much better looking now. That tip looks nice and clean. And then I like to start with, you know, if we have a part that has a whole lot of pins like this, I get my solder and I just start by soldering one pad. So, you know, they always say, you know, apply heat and then apply solder to the heat. That doesn't necessarily apply here. Sometimes we have to get a little solder on the tip. So what I'm going to do is I'm just going to pre-tin this tip a little bit. Just put a little bit of solder on the tip. Be sure to wear glasses. So you see I got a little ball of solder there. That ball of solder is going to get that first pad connected. So little tiny ball of solder, touch the first pad. Okay. Now if you look at that, now on this board, that top right pad is soldered. And the board's not perfectly aligned, but just with that one pad soldered, if we did have to adjust it, we can reheat it and kind of bump that thing into a new position if we need to. It's good enough right now to solder, so the chip is a little shifted low, but it's going to be fine. It's going to grab those solder pads. So now that I got that one part on there, I'm going to switch to probably the other corner. So it's on there, it's aligned okay. I'm going to switch to the other corner. Feed solder in on that pad. Oh, it's being a pain now. Okay, so now that I have two corners soldered, with two corners soldered, this thing is not going to go anywhere. So I think I got two corners soldered. No, it looks like I didn't. Yeah, okay, so now I got two corners soldered. Two corners soldered, that one's good, and that one's good. Okay, so we got the corners of that chip. So now this chip is not going anywhere. If we bump it with our finger, it's not going to move. It's not going to budge. So now we're just going to go through and solder all the rest of those pads. So just one by one. We really want to make sure that the solder makes a nice meniscus between the pin and the pad. And even if you're not using a microscope when you solder, I suggest you just use a microscope at least to inspect it at the end. So the biggest mistake students make when they solder is they don't use enough solder and they don't use enough flux, or they don't hold the heat long enough and they don't use enough flux. So I maybe didn't use enough flux here, so I'm going to load it up with a little more flux. And you see, with plenty of flux, one thing you'll notice, with plenty of flux, you can actually just go through here and just, you know, you can kind of almost scrape the soldering iron across the edge of these pins, and the surface tension will kind of get that solder to go where it needs to go. But you can see how we kind of got all those pins soldered. They're not all soldered. I probably should have actually adjusted this part. Probably should have gotten it more on there when I started. That's fine. This will be a more accurate representation. So I'll just keep going, making sure. You don't want to just make sure there's solder on the pin. You want to make sure there's solder on the pin and the pad, and that it bridges that connection. So holding heat a little bit, letting it flow on there. That all looks good. So yeah, you can see the part's a little shifted. But all those pins are soldered now. Yeah, they look good. So now we'll do the other side. And again, if you start having issues with it, just put some more flux on there. It'll be fine. If you get a bridge, if you get pins that bridge, it's not a problem. If you do get a bridge, you can usually just kind of scrape it off with the iron. Looks like I might have missed a couple here. So if a bridge happens, usually you can just, you know, scrape at it with the iron and it'll be okay. Or if you need to, you can use braid to get rid of it. So all these seem good. They seem okay. So I'll deliberately form a bridge right now just to show you what to do. So if you're putting too much solder on here, oh, and you get a bridge where it does that, where those two pins are bridged right there. So normally you can just kind of give it, you know, brush it a little bit with the tip. Maybe clean the tip off on the sponge. Brush it a little bit more. Yeah, see now I was able to brush it out. If you can't brush it out, you can always use solder braid. So solder braid's another way to kind of suck some solder off of the surface. If you start having issues, talk to me or talk to Reza. Also, if you get it mostly soldered and there's like one chip that's having an issue, you can leave it messed up until I get back and then we can talk about it. Or we can get it figured out. So if you get it mostly soldered, that's probably good enough. We can clean up a little bit of an issue. The main thing is if you know there's something wrong, like there's something not soldered right or something not connected or you're not sure, don't energize it. So leave it unenergized. So, okay, so next thing we're gonna do is we're gonna go through the schematic and we're gonna start doing parts by part. I'm gonna start with the big 10 microfarad capacitors. So the 10 microfarads are C4, there's one right here, and C3. So C4 and C3 are the 10 microfarads. I'm going to take those and take my tweezers here. Okay, so we got the two big ones. So C4 on my board, C4 is right here. So we take that part. And again, we're going to cheat and get a little solder on the iron. Like that. Put C4 into place, and we're gonna hold it down. You want to make sure it's flush, and then we're gonna add that solder. So sometimes these parts are floating off the surface. You don't want them floating. You want them on. You want them down. You see that one side soldered. You really want them down flush. If they're kind of up at an angle, it's hard to get the other side on. So like I said, I just like to do one side of the parts at a time. That allows me to still move them if I need to, so that one's good. So the other one is C3. Again, getting a little bit of solder. Okay, so we're going to go over to C3. Okay. C3 appears to be on. So now we're done with the big 10 microfarad ones. Now we got a whole bunch of these little 0.1 microfarads. So C6, C7, C5, C1, these are, and C2, these are all 0.1 microfarads. So we need a bunch of 0.1s. What I like to do to make sure you don't mix up parts, another thing that students mess up when they're doing parts is they, if you have loose surface mount parts, it's easy to get them mixed up. So I always keep the space clean, and I only release parts, I only allow parts to be loose one part at a time. And once I'm done with that part, I close it back up. So we're going to peel back this S surface mount strip. And I think we need at least 5 of these. So 3, 4, 5, I'll dump those. Okay, so we have 5 0.1 microfarad capacitors. We know, oops, you can't really see them, oops. So they're right there. We have 5 of these 0.1 microfarad capacitors. So we'll start, so C5 is one. And another thing you can do, and this is another, almost an easier way to do it, you can pre-solder one of the pads. So if we go in here and we just get some solder on one pad of C5, not both. If you get solder on both sides of C5, you're not gonna be able to lay it flat. So one side of C5, and then we got C2. C2 is here, so we'll do one side of C2, and then C1, one side of C1. Oops, looks like I accidentally got one side of R4. I kind of got both sides of C2 there now too. Okay, and then C7 and C6. So looking at this board, you can see there's little balls of solder on one side. So you look up at the top, C7 and C6, there's a little ball of solder on one of the pads. So then we're gonna go in to like C7, and we're gonna take our capacitor, pinch it, and then we're gonna set it in place and remelt that C7 and slide the capacitor into place. Sometimes they get a little sticky. Okay, well now we got an issue. These tweezers have they're a little bent. Okay. Okay, so take another capacitor, so we'll do C6. Again, so melt that pad, slide it into place. Let it go. And then we also got C5. And so we did C6, C7. So we have C5. And then C2. C1 and C2. So C1 and then C2. And they like to try to go vertical. That's called tombstoning. So sometimes when you only solder one pad, they tend to like to go a little vertical. So right now, you see C2 there is kind of up at a little angle. So it's not quite flush on the surface. So what I'm actually going to do is go back to C2 and just put light pressure on the top of it and remelt that pad. And then that light pressure should pop it down flat. Oh, actually, the reason C2 was up was because I accidentally touched that surface with a little bit of solder. That's fine. So we're going to inspect it really quick. Just make sure we got, solder on one side of each pad. It looks like they're all okay. Now we'll go on to so we finished with capacitors. I think all the capacitors are done now. Let's do the inductor. So the inductor is right here. And if all you're doing is one when you're done with it, so these are the inductors. If all you're doing is one when you're finished with it, you can get rid of the part if you want. So we'll take that inductor. Gotta be sure to stay in screen here. Sorry, I'm kind of getting out of screen. Maybe I can tilt it a little bit. Phone case is kind of sagging a little bit. Well, that's as good as I'm going to get. Okay, so the inductor, we'll take the inductor, and once again, we'll just do one side of it. We'll pre-tin that pad. Get a little solder, touch it to one of the pads. Put the inductor, add heat, let it go flat, maybe tap the top of it, let it go. Okay, the inductor's on there. What next? Now I guess we could do the transistor. So Q1. So the transistor is here. You can leave the part on the if you tape the side that doesn't have the peel tape, you can just fold it back and pull it off to peel a part off. So I kind of sent it shooting here. So this is the transistor. The transistor has 3 legs. It only fits in one orientation here. So it only fits in one orientation. Once again, we'll start with one pin. Put it here, get one pin, and then after we get one pin, especially with these parts that have more than one leg, you really want to make sure after you get one pin that they're aligned. So you see that Q1, that transistor up there, it looks like it is aligned okay on those pads. Okay, what do we got here? So we got, let's do some more weird stuff. So we'll do R6 and R5. R6 and R5, these are the precision 1K resistors. So if you're using, these resistor values have to be associated with your strain gauge. So if you're using a 350 ohm strain gauge, you need to choose the precision 350 ohm resistors. If you're doing the 1000 ohm strain gauge, you do the 1000 ohm resistor. So I'm doing the 1000 ohm strain gauge. So I'm going to peel back the precision 1000 ohms. Those pop down here. Okay, so if the part flips, if a resistor flips, like it just did, you can flip it back up. The top of a resistor is typically black. The bottom of it is white usually. So R5 and R6, these are the same value. We'll once again pre-tin the pad. And this one's going to be in a pain. It really helps to not have too much caffeine, not have too much alcohol when you're doing this. It does help to have a steady hand. So that looks okay to me. Yeah, so those two precision resistors, they are close enough on there. Now you got to see the other pad that's not soldered. You have to leave enough space that you're going to be able to get solder in there. So sometimes when you solder the first pad, you kind of want to push the part up against that pad so it leaves enough gap. So it leaves that gap up there for the other one when you eventually come back and solder it. Okay, next we'll do, well, let's do these 100 ohms, R1 and R2, the 100 ohms. So R1 and R2 here. These 100 ohm resistors. And again, as I'm going along, I'm making sure the only parts that are ever free are the parts I'm dealing with. So these are both flipped. We'll flip them back around so the black side's up. Sorry, my hands are gnarly. I understand cuticle health isn't great. This finger especially, this finger which is currently injured, but I hit it with a chainsaw a few years ago and it's kind of, it looks like I hit it with a chainsaw. So R1 and R2 right here. You got to pay extra if you want an education with people with pretty hands. That's like MIT level stuff. I'm no JP Pruitt. I'm no JP Pruitt. Reza, do you know what JP Pruitt's from?
No, what's that from?
It's from Zoolander. It's the hand model played by David Duchovny, who was
George Costanza.
Was George Costanza a hand model?
It was.
Interesting. We have a clash of cultures here. George Costanza was also a hand model. Okay, so R1 and R2. Just I kind of need to look at it under the camera to see that it looks okay. Yeah, R1's a little wonky, but it's going to be okay. So I'm going to be able to solder it. It's going to be okay. If we want to adjust R1, we can. Yeah, I'll just adjust R1. So get in here, put a little heat on that one pad. Again, we can adjust it because there's only one pad that's soldered. If there had been two pads soldered, we'd be in real trouble. So now adjusted R1. Looks better. Now R1 and R2 are there. They're looking good. So R3 and R4 now, these make the divider for regulating this output voltage. So 20K and an 8.2K. So we'll start, we don't want to mix these up or it's going to mess everything up. So R4 is 8.2K. Let's get one 8.2K here. This one's kind of a pain. It's kind of stuck in there. Oh no. Here we go. Okay, so that's our 8.2. So we'll double check that 8.2 is R4. We'll go to R4 is there. Yeah, I accidentally kind of already soldered R4. So I already soldered the bottom side of R4. So we'll just make that the pad 1 that we soldered. Okay. R4, 8.2. 20K is R3. As you're watching this video doing your soldering, just rest assured knowing I have abandoned you and I am in Mexico enjoying myself. So you're working hard and I am probably drunk on a beach somewhere, not able to solder because I did not take my own advice of avoiding caffeine and alcohol before soldering. Yes, okay. What's left? Let's do the... Okay, so the main circuit is done. We have the LED circuit though still to do, and these resistors here. So the resistors for the buttons, I say 20Ks here, which is fine. They just have to be kind of something big. So let's do the 20Ks for the resistors down there, for the buttons. Okay, 20Ks. I don't think I pre-tinned these, so. Okay, got those done. Really, for the buttons, any resistor value between about 5K and 40K should work just fine. One resistor. See, sometimes when these tweezers sometimes magnetize or they get sticky flux on them, and so sometimes you gotta clean them with alcohol. Alcohol is the safe material to clean these things with, so we typically have bottles of isopropyl alcohol nearby. So R9 and R10 are now on there. They look okay without checking too much. The buzzer, so R11 and Q2 I'm going to avoid. Now the LED resistors. So the LEDs are 1K resistors here. Let's get those two 1K resistors. Now, resistors and capacitors, at least these capacitors, it does not matter the orientation you place them in. The LEDs, it does matter. So the orientation of the LEDs matters a lot. So 1K. 1K. So these are R8 and R9. Oh, R7 and R8, which are R7 and R8 here. Tin pad. And you'll notice I can go for a while sometimes without adding more solder because surface mount parts don't take up a lot of solder. So a lot of times just the stuff that's left on the tip is fine. Okay. R7. And uh-oh, where'd the other resistor go? Oh, here it is. Okay, so now for the LEDs, I have a couple reels of them. So this is one, these are LED red clear. There's a couple different standards for LED labeling, but I'm going to kind of show you really closely here. If you flip over the LED on the back of the LED has, see, that's what it looks like. So there's two ways to think about this. You can think about this like, you can think of the green making an arrow, or you can see the white C there. So you can either think of it as the green's like a little pixelated arrow, or you can think of the white that is next to the green makes a C for cathode normally. But let's just treat it as a green arrow. we treat it as a green arrow, if you look at your board, the LED labels, the LEDs have a little triangle inside of them. See that little triangle shape, this point to the left in here? So we can think of the little triangle shape as if we think of the direction of that triangle arrow, we want to have the little green pixelated arrow in the same direction. So I'm going to show it upside down. Just to show the direction here. But when this is flipped over, see the arrow and the green? So the green makes a little pixelated arrow. The arrow on the silk screen is pointed that direction. That's the direction we want this LED facing. I totally forgot which one this was. This was the green, I think. Okay, so it doesn't really matter which one we make the green LED in this case. I'll just, oh no. Yeah, I'll just do the one on the left as green. Eventually we'll have to decide that by how we, oh man. We'll have to decide that by how we wire it, but, so I'll make the one on the left the green LED. It needs to clean the tip a little bit. So get that pad. Okay. We'll do the other one here, and for this one I will use, these are the red LEDs. These ones are a different brand, but they're going to follow kind of the same convention. Oh wait, no, this is still the green. No, this is the red. I think I put a red on there. Shoot. Okay, well the left one that I just put on was a red. The right one that I'll put on now will be a green. So LED green, 520 nanometers. Okay. So once again, if you look at the bottom side, you see a little pixelated arrow, or again, you can, the white is C for cathode, or you can think of it as a little green pixelated arrow. Either way should work. Just make sure the orientation's right. Okay. Okay, so now those two LEDs, one side of them at least is soldered on. So now all of our parts have one side soldered on. So the next thing we're going to do is just go through and solder the other side of everything. So, but they're all in place, they're all secured. So soldering the other side of everything is quite a bit easier than soldering the first side. And you want to make sure the solder melts both the part and the pad. So you want to make sure it actually gets melted on the pad. Sometimes it's easy, especially if you didn't leave yourself a lot of room, it's easy to only get heat on the one side of the part and it won't be actually touching the pad. That'll mess you up. So you're going to want to go back and look at everything under a microscope anyway. Oops, and that one, yeah. If you touch the side you think you need to solder the pad and it moves, that means you're touching the wrong side. You got to solder the other side too. Okay. A little worried about that transistor. I think it's fine. Okay. Okay, got everything there. I can just sometimes I just go back and touch it. Just, oh, nope, didn't get these ones. And the other side of the LEDs. I'm just going around touching both sides just to be sure. And these down here. Okay, I think we got everything now. I think that's that's all those parts soldered. I'm just gonna check under the microscope really quick for any issues. It ain't pretty. It ain't pretty, but I think we're good. Yeah. Yeah, that's everything connected. Okay. Yeah. Okay. All right, so everything's good there. I'm going to show you, I'm going to do these buttons now. Now there's two types of buttons. There's the through-hole buttons, right? So there's these types of buttons. We don't have very many of these, but these are fine. If you have these through-hole buttons, you can just pop them in. And the good thing is they get a really good friction fit, right? So you just pop them in, and then they're easy to solder on the back. If you're using, you can also easily do surface mount buttons, which surface mount buttons we have a lot of. The problem with the surface mount buttons is you got to bend them a little bit to get them to work. And I don't know what I did with my surface mount buttons. Oh, they're right here. So the surface mount buttons are right here. If you wanted to use a surface mount button in a through-hole part, it's fine. What you do is, though, you just have to bend in, so you see the legs on here kind of stick out. You just got to bend them against a table or something to flatten them out, just to straighten them out so they stick down instead of out. So you can't see it, I'm off camera, but I'm just pushing them against the side of a table. And see, now they look like that. So now they're squished in. And then that, we can just put it pop it in like this. And you gotta give them a little squish. And beautiful. So now that surface mount button is in there, like that. So just those little surface mount legs are now just pop through the hole. What I like to do is keep finger pressure on the top, go around to the back, squeeze a little flux in the holes while keeping finger pressure. Get your solder iron, get a big old glob of solder on there. And then with that big old glob of solder, just touch the hole, and then it's gonna suck in there, and you want to let it wait because you want to give it enough heat till it solders the top of the, you want that solder to flow all the way through and solder that pin too. So as soon as you get one pin, now this thing is secure. We can just go to the rest of the pins. Feed and solder in these things take a lot of solder just because the holes are thirsty. And I'll do the other one really quick. Okay. Buttons are done. Only thing left to do is headers if we want them. So we have lots of different types of headers. We have vertical headers, we have right angle headers. So I'll do right angle headers. So these are breakaway headers. So they're a strip that can be just split. You can see it's got little indentations. So if I want 3, I can just snap them off. Just with your fingers you can do it. And then the other side is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Snap those off. So you can take this row of headers you just snapped off. Hopefully you counted right. Put them in place like that. Now what I like to do is you got to keep these level, right? So again, finger pressure, holding them in the hole like that. Just at least get flux on one. At least get flux on one. Grab some solder. So flux on one. Solder. Now you want to be sure your finger's not touching the one you're soldering. This metal conducts a lot, so if your finger's pushing on the pin that you're soldering, you're going to burn your finger. It's not the end of the world, it's not great. So now we're going to come through here and we're just going to rapid fire hit the, I gotta go with flux. So flux.
Have fun in Mexico, man.
Thank you, Daniel.
I don't know if you said you're leaving tomorrow, right?
Yeah, yes I am.
You're probably the group you're going with, so we're going to get started with the lounge airport drinks.
I don't know. Well, maybe, probably. They're not huge party people that are going here.
Didn't you say somewhere like partying and getting drunk?
Well, they're dumb people, but well, I shouldn't say that. This video will be on the open internet. They're not dumb people. They're brilliant people who do not get scammed.
You're recording this right now?
Yeah, I'm recording this right now. That's fine. That's fine. We're almost done here. It's fine.
Are these more offending than yours?
What?
These glasses, or is it the one you got?
They're not. What do you mean, offended or?
Authentic?
Oh, authentic? Oh, the glass is authentic?
Yeah, I got these.
Those look equally fake to mine. Are those? What are those?
These are real Ray-Bans.
Real Ray-Bans?
Yeah.
Interesting.
And supposedly they were date marked from the 1980s. The box set, though.
Little wonky. I probably should have straightened that out before I soldered it, but whatever. So now we have fully finished board except for the buzzer and the transistor. Now if we want to clean it up, which we definitely want to do, we take our board, we get some alcohol. This is the isopropyl alcohol bottle. And we get a brush. And I'm going to make a mess as I do this. It's fine. So we're just going to brush, just scrub it with alcohol here. Get a lot on there. Scrub it. And even down here. And all we're doing is we're getting that flux off in the back. Scrub it. And then we'll take a Kim wipe. Wipe it off. Beautiful now. Now we have a finished soldered board. All the components are on there. It should be working perfectly. Good luck on yours.